ما سويت شيرنج. وايد شغلات صارت يعني. Okay, so we are at the end of half of the semester, and today is the last day before the semester break. So I will talk about solution of this one. If there is chance, I will talk about chapter 3 because we finished chapter 2 already. Okay, so in this one, this is the question number 1, and it looks familiar, right? Which is one of the tutorial problems. Yeah, at the end of tutorial. So question A and B, I think they are already in the tutorial. I added part C only. Okay, so the question is a 35 kilogram block is supported by the spring arrangement shown. The block is moved vertically downward from its equilibrium position and released. So we have initial displacement only. And knowing that the amplitude of the resulting motion is 45 millimeter. Amplitude is given, so we don't have to find, we don't need to know the initial conditions because amplitude is given. So it is the amplitude, the response will be amplitude times sine omega t or cosine omega t. Determine the period and the frequency of motion in radian per second. B, determine the maximum velocity and maximum acceleration of the block. If a viscous damper is to be added to the system so that the damping ratio is zeta equal to 0.2, what will be the damper constant C needed? So first of all, we look at the arrangement of the spring. They are 3 in parallel because they have the same deflection. So K equivalent is going to be 16 plus 8 plus 8, which is 32 kilonewton per meter. And then you can find tau n. This will give us the equivalent system. The equivalent system is one spring and the same mass. So it is 35 kilogram. And this is K equivalent. Okay, K equivalent is 32 kilonewton per meter. So once you reach to this system, you can find omega n from square root of K equivalent divided by m, and tau is equal to 2 pi square root of m over K equivalent. So here is the tau n is 2 pi square root of m over K equivalent. It becomes 0.208, and omega n is required frequency. So if you find Fn or you find omega n, both are okay. It's 30.24. Okay, then part B, the maximum velocity is x dot maximum equal to A, which is the amplitude given 45 times omega n. 45, I converted to meter because I found the number is high. So it is 45 times 10 to the power minus 3 times 30.24. It is 1.36 meter per second. You can check the numbers because I did this with my phone, in the calculator in the phone. And x double dot maximum equal to A omega n square, 45 times 10 to the power minus 3 times 30.24 square, equal to 41.15 meter per second square. Then the last part. So in order to answer the question, we need to find zeta, or zeta is given, we need to find Cc. So Cc is 2m omega n for this system. Okay, and then you can find Cc. 2 times 35 times 30.24 equal to 2116.8 Newton second per meter. And zeta definition is C over Cc. We can put C on one side. It is zeta times Cc, 0.2 times 2116.8 equal 423.36 Newton second per meter.
كان عندي سؤال بس نسيت ما سألته قبل تسألنا. الحين كان عندي أكثر من دامبنج.
ما في فائدة، راح الوقت.
لا ما يعني شنو ما جبت.
اوكي.
إذا مثلا في 2 دامبنج elements.
اوكي.
هل تهم الكونفيجريشن مالها؟ يعني نفس السيرفيس elements؟
اي.
يعني مثلا parallel series.
اي صح. يفهم. Okay, question number 2. A massless rigid bar is pivoted at point A and carries a mass m equal to 6 kilogram at point B. The bar is restrained by 2 springs, each of stiffness K equal to 600 Newton per meter and mass ms equal to 1.5 kilogram as shown below. Determine the effective mass M effective at point B, يعني at this point here. Effective stiffness K effective at the same point B. The nature frequency of the system. Take L equal to 700 millimeter and B equal to 500 millimeter. On purpose, I didn't change those values so that you will familiar question. And already one of the previous questions, 700 to 50 and 500, so that you don't feel this is something different. Like, as you can see from the arrangement, this is horizontally supported. It is pivoted at point A. The bar is pivoted at point A, and it is massless. The springs are not massless, so this will be an equivalent to this. You have to make it in steps. The first, if you don't want to do it, you make a sketching, but you should think that this is going to go through 2 steps. The first step is to consider the masses of the springs. So you put the bar pivoted here, and there is the mass M, and there is the mass of the spring, the added mass of the spring at this location, at distance D. Okay, the mass of to be added is ms over 3 and ms over 3 because they are identical springs. So you multiply by 2. So this will be 2 ms over 3 at this point. At this point, which is distance D, and at this point, which is distance L. And then this will be same as the example number 8. In example 8, it was a 3. And of course, we don't. We have to put the springs. Yani the spring are K equivalent is 2K. The 2 springs are in parallel. Yeah, but the method we explained was the energy method. That is easier. Okay, if you want to use Newton's second law, you will reach to the same solution, but if this is the first time you are trying, you will do some mistakes. Okay, if this is the first time. Okay, so if you try the test, that is not wrong, but it might be you will not reach to the correct solution. Okay, so this becomes the equivalent system, and then the required step or the final step will be K effective with M effective at XB. This is the system required. So how do we obtain K effective and M effective? K effective is from potential energy, and M effective is from the kinetic energy. And so here what I did, the rigid bar will give you a relationship between the points. Okay, we have point B here and the point at the spring. So I called it XS, which is the motion of the spring. I can just add, this is the center line. Okay, here is the center line, and this is the arbitrary position. Here is XB, and at the mass, I called it XS, the motion of the spring, and then displacement of this of the mass or at the point at the spring, and this is theta here. So you can see there are 2 triangles, 2 similar triangles. This is number 1, and this is the second. So there are relationships between XB, XS, and theta. Okay, so XB is L theta, and theta is from here XB over L, and then XS is D times theta, and substituting for theta, it is D over L XB. And then we use the kinetic energy. So the first thing is you have to put the kinetic energy with using the velocity of the mass of each mass. So half m xb dot square plus half 2 times ms over 3 xs dot square. So this is the kinetic energy, and then you substitute for xp dot and for x s dot in terms of xb. Xb is there is no changes because this is the same. So only xs dot to be So we substitute this for in terms of xp dot. And then we get 6.51 xp dot squared. So this is the M effective. Okay, the potential energy, it comes from the spring only because this is supported horizontally, and that the weight of MB or WB times mg times mg, I mean, and also the masses of the springs ms over 3 times g also is supported by the springs. So this is the equilibrium position. We don't put the work of the masses or weight unless if it is supported vertically, this one vertical. If it is vertical, then we have to include the work due to gravity. So it is half, two springs in parallel, 2K, and both are at S, so it is XS square. Then we substitute for XS in terms of XB, and we get the K equivalent. We have to keep the factor half here and XB square here. So K effective is 612. 612, right? And that one 6.5. So this is K effective. And once you reach, you find K effective and M effective, natural frequency is square root of K effective over M effective, which is 9.7 radian per second. Okay, question 3, 2 kilogram. Somebody said the frequency is imaginary. I know because this is overdone. The 2 kilogram mass is given an initial velocity x dot at 0 equal to 10 centimeter per second to the right from the equilibrium position. Determine the frequency of timed oscillations. It means omega d or ft. Okay, the displacement and velocity of the mass at the time t equal to 1 second. Okay, so we need to find for problem that is damped system, we need to find zeta. We cannot find the frequency or the response or the displacement before we find zeta. So the first thing you have to find zeta. And omega n is square root of k over m because this is a spring mass damper system. Omega n is simply square root of k over m equal to 7 radian per second. Cc is 2m omega n equal to 2 times 2 times 7 equal to 28 newton second per meter. Zeta equal to c over cc. C is 42. Then it is 42 over 28 is 1.5. And which is greater than 1, which is overdamped. And for overdamped, we mentioned this in the class. There are no oscillations, so the frequency is 0.
إذا كتبت imaginary part.
And you have to explain the meaning of the imaginary part.
أنا كتبت إنه of them system.
Okay, no, but how much is omega d you found? Imaginary, there is no frequency imaginary. شخبط عليهم.
imaginary part 7.826R. هاي كتبتها.
إذا وش معناتهم؟ وش معناتهم؟
ما في oscillation لأن أصلاً الزيت أكبر منهم.
إيه، زين ليش بخلي لي بعد imaginary؟
وليش ما نكتب له دكتور هاي السؤال؟
لأنه ما في frequency لا. And there is no imaginary frequency, there is no negative frequency in life. Huh? لا, because this is damped system. Damped. There is omega n is the frequency of undamped if you remove the damper, but when you put the damper, it will not oscillate. If you put the damper with this value, the mass will not oscillate. It is a vibratory system, but without oscillations. And for overdamped, you don't try even square root of 1 minus zeta squared because it is imaginary. That is only for the underdamped. The omega d equal to omega n square root of 1 minus zeta squared is only for zeta less than. That's it. That's the only case the oscillatory system or the oscillatory case. The other two, critical and overdamped, are non-oscillatory. Omega d 0. This is what I understand of non-oscillatory.
زين دكتور إذا كتبنا imaginary part.
ما في frequency imaginary.
زين بس دكتور يعني موجودة imaginary part صح؟ real part 0 من كذي ما في يعني oscillation. بس وجود imaginary part ما يعني ان السيستم صار oscillatory.
Okay, now the question is very clear. what is the frequency of damped oscillation? If you answer that question, if you say that the question, that the answer, the frequency is 7 point something I, then I will give you 0.
زين كم عليها هاي التسجيل؟
مكتوب لا؟
دكتور انا هاي السؤال كمان بس هاي هم قال لي كم عليها.
اوكي انت تعلمت شيء الحين بس ما عليك من الدرجات. Okay, the part B, displacement and velocity of the mass at the time t equal to 1 second. So this is the crucial idea, that once you find zeta, then you can select the proper equation of response for overdamped. Okay, this is the equation for overdamped. لا تقولوا اخترتون غلط، موجودة في الفورمولا شيت. And I didn't write the name of each response, that this is underdamped, this is overdamped. يعني شو اقول لك؟ بعد الناس تسال، لا الناس الحين تسال يعني شو اقول لك؟ صار اونلاين، كان كل شيء عند الطلبه عندهم كل شيء زين. والمشكله ما تغيرت، يعني لازم تكتب لهم اي هو اندر دام اي هو اوفر دام، لان هي الفورمولا شيت مساعده مو حق دراسه، مو حق واحد يدرس من الفورمولا شيت، حق ياخذ منها المعادلات اللي ما تنحفظ، بس من كثر الاستخدام ترى انا حفظتهم، يعني من كثر الاستخدام، ما اقول لك ان انا حافظهم قاعد تتحفظهم، بس من كثر الاستخدام وحل المسائل تقريبا اذا بغلط فيهم قليل يعني. فعلى العموم والشرح اللي شرحته يعني حرام يروح كذي اشرح لكم اي هو الاوفر دام، اي هو الاندر دام، اي هو الاوفر دام، بعدين يسالني الطالب اي حق الاوفر دام، زين فكاني ما شرحت شيء. So we need to find A and B. Those are the constants, and they are equal. But I mean A equal to minus B equal to minus A because that x as 0 is 0. Okay, if you go to the formula sheet. Okay, this is the overdamped response. A equal to x dot plus a term multiplied by x0, which is 0. So this term will be 0. And the same thing, B equal to minus x dot 0 minus a term multiplied by x0, then this is also 0. So this will reduce to that B equal to minus A. Just to make it, I made it simpler. And it was the question I found in the textbook was x at 0 is given, but not x dot was 0. So I just made it easier.
بالنسبه لها النقطه الحين الاكس ات 0 تساوي 0 لان السيستم اوريدي في الاكويليبريم.
Yes.
بس لو كان في سترايك مثلا لازم احسب اكس ات 0.
لا even if there is a strike and the mass was at origin or at equilibrium, then x at 0 is 0. حتى لو vertical. Then the equilibrium position is the datum. to measure.
طاحت على السبرينج من فوق. اي السؤال مال
اوكي الامتحان السابق كان spring without the map.
كان في سترايك يعني.
Okay, that is something else because we measure from equilibrium. This is a massless plate, and then you have a mass from the top. When this mass in engagement with the spring and the damper, this will take equilibrium position. This is the equilibrium position. Vibration after this mass strike with the plate will be about this line. So initially the system has initial displacement minus delta for this problem. Okay, here already the mass is at equilibrium. Okay, so we find A, then we find B equal to minus A, then we substitute, we get X, and then differentiate to get the velocity. And then at t equal to 1 second, you get x at 1 and x dot at 1, by 0.0441 minus 0.1178. Okay, so that was the solution of the test.
دكتور من السؤال هذا والله عدلته على حسب ما شفت الامتحان
هذا
شفت الامتحان شفت انه مطلع دلتا عشان استعمل هني x equal 0.
اوكي
فهمت الامتحان مع نفس الشغلات فعدلته قلت ان هذه هي اكس ايكوال 0.
اوكي.
فمو نفس القضيه على اساس انه كذا
يمكن إن لا this is to the right from the equilibrium.
هل اقسام ما كانت equilibrium؟
لا. That was before the strike. The system is not oscillatory. Is not a vibrating system. You know, this system is not a vibrating system. It becomes a vibrating system if the mass is engaged with the spring and damper.
السؤال مال تيست سابق يوم في هذا السؤال كان اكس 0 بالماينس لكن اكس دوت صايره بالبوزيتيف.
بوزيتيف صح.
بس شلون نتخيلها شلون يعني؟
اوكي إيه.
ما فهمت.
اوكي هذا الاكويليبريم position is here. We take positive downward, right? So originally it is above the origin, above the equilibrium. So it is negative. X at 0 equal to minus delta. It is above the equilibrium, above, in the negative direction. The velocity is downward, which is positive. الحل مالي كان صحيح في positive كذي.
دكتور في احد حلها جزئيا بالتنقى؟
ده
يعني نطلع
هذا ما اتوقع ان حد حل دي يعني. مو مشكله في افكار واجد فانت ما تقدر تغطي كل شيء في التست، قصدي في الصف يعني. ف تجيب بعض الافكار اللي ما انشرحت في الصف، يعني مو ما انشرحت بالتفصيل يعني، بس لكن انا قلت ان كل vibration is about equilibrium. والx at 0 and x dot at 0 measured from equilibrium position. اوكي. امتحانكم كان في نظري بسيط يعني وابسط من الامتحانات السابقه. يعني حتى ما جبت يعني what is the maximum position او البيك الاوفر شوت ما جبت. ما بس يعني هو هذا السؤال اللي كان فيه derivation حق equations. بس البقايا كلهم straight forward. Okay. We will start inshallah chapter 3 next week. Not after semester break. We need to have a quiz. Usually I give 2 quizzes before test 1, but this time I don't know, either we were busy maybe with the lectures. I don't know what was the problem. We took only 1 quiz. So usually we take quiz before 2 quizzes before test 1 about tutorial 2 and 1 about tutorial 3. Usually. So after semester break, we need to take a quiz. I will send you a message during the break and tell you which are the date and which lecture. And maybe the end of maybe Thursday or something like that during lecture time. يعني within tutorial chapter 2 يعني maybe tutorial 5 يعني or 5 yeah.
تقدر تصير تخلي يوم الأحد مو أول ما بدي يوم الأسبوع
اللي بعده. أوكي. لا أوكي. عندكم امتحانات بعد؟ Okay. So I will tell you about the date. يلا في أمان الله. أونلاين في أحد عنده سؤال؟
يعطيك العافية دكتور.
الله يعافيك. يلا مع السلامة.